Today, let's discuss a few problems from past papers. So question number 1 is a curve has equation y is equal to half x square minus 4x raised to 3 by 2 plus 8x. Find the x coordinates of the stationary points. Okay, let's consider the equation, which is y is equal to half x square minus 4x raised to 3 by 2 plus 8x. Okay, and we know to find the stationary points, we have to make use of dy by dx, the derivative, which is equal to 0. Okay, so dy by dx equal to 0, dy by dx greater than 0, and that is less than 0. These are the three concepts we discussed in the last class. And you know, if dy by dx is equal to 0, which gives us the critical value, which is the stationary point, which is maximum or minimum value, and dy by dx less than 0 and dy by dx greater than 0 makes decreasing and increasing function. So as dy by dx is equal to 0, we are finding dy by dx, that is half of derivative of x square is 2x minus 4 into derivative of x raised to 3 by 2 is 3 by 2 x raised to 3 by 2 minus 1, using the formula d by dx of x raised to n is equal to n x raised to n minus 1. Isn't it? It's plus 8 into 1. Okay, so that means dy by dx is equal to half and 2 get cancelled. We get x minus 4 and by 2 get cancelled. We get 6 x raised to 3 by 2 minus 1 is 1 by 2 plus 8. As dy by dx equal to 0 with the concept of stationary point, we get x minus 6x raised to 1 by 2 plus 8 equal to 0. Now we have to convert it into the quadratic equation. For that, we need to assume x raised to 1 by 2 equal to a and x is equal to a square. As per the chapter 1 quadratics, we learned the same thing in the complex quadratic equations. So it implies when we replace, we get a square minus 6a plus 8 equal to 0. Now you can use either factorization or quadratic formula or completing the square. Here I am using factorization. So minus 6 can be factorized as minus 4 minus 2, and 8 can be factorized as minus 4 into minus 2. So after the factorization, we get the result as a minus 4 into a minus 2 equal to 0. It implies a equal to 4 and a equal to 2. So we get two values for a, which are 4 and 2. But our final result is not a. We have to find the value of x. And we know that x is equal to a square as per our assumption. So for the first value of a, we get x as 16, and the second value of a, we get x as 4. Those are the two results. Those are the two x coordinates for the stationary points. Examiner report. The requirement to differentiate was well understood and successfully applied. Some candidates solved a quadratic in root x and squared their solutions, while others chose to rearrange their quadratic and square both sides, usually correctly, to obtain x directly from the resulting quadratic in x. Find d square y by dx square. Okay, that's the second question. So from part 1, we get dy by dx is equal to x minus 6x raised to 1 by 2 plus 8. So differentiate this equation once again. We get d square y by dx square is equal to 1. Derivative of x is 1 minus 6. Derivative of x raised to 1 by 2 is 1 by 2 x raised to 1 by 2 minus 1 plus 0. Derivative of constant is 0. That implies 1 minus 6 by 2 is 3 into x raised to 1 by 2 minus 1 is minus 1 by 2. Yes. So this is the second part of the question. And the third part of the question is to find the nature of the stationary point. We know that d square y by dx square is equal to 1 minus 3x raised to minus 1 by 2. And we are using d square y by dx square to find the nature. So let's take the stationary points x is equal to 16 and x equal to 4. When x is equal to 16, d square y by dx square is 1 by 4, which is greater than 0 by replacing x value. When x is equal to 4, d square y by dx square is 1 minus 3 into 4 raised to minus 1 by 2, which is minus 1 by 2 less than 0. Now recall the concept. If d square y by dx square is greater than 0, then what will be the nature? Just recall what is the nature. Yes, that gives the minimum value. That gives us the minimum value. And if d square y by dx square is less than 0, that gives the maximum value. Okay, this is a concept. So with the help of this concept, we can find the nature of the stationary points easily, where the points minimum or maximum. At that same time, recall the concept of finding the nature using dy by dx. Okay, so for that, let's consider both the stationary points x is equal to 16 and x is equal to 4. So when x is equal to 16, you have to take the number line where 16 is a point. Now consider the left side and right side of 16. Left side gives the value smaller than 16, that is x smaller than 16, and the right side gives you the values which is bigger than 16, that is x greater than 16. Now take two convenient points, each from the sides, either side of 16. Take one value from less than 16 and one value from greater than 16. Conveniently, I am taking two values. One is 15 and other is 20, 25. Any values you can take. Okay, that's our wish. Okay, even less than 16 you can take 0, any value, that is our convenience. Okay, so I am taking here a value which is 15, and from x greater than 16 I am considering a value which is 20. Now substitute these values in dy by dx. Remember, dy by dx, we get x is 15 gives you the decreasing value, x equal to 16 gives you 0, x is 20 gives you increasing value. Okay, and if x is equal to 4, there also you choose two values, one is less than side and another is greater than side. Less than side I am choosing a value 0. Okay, and for greater than side I am choosing 6. Now substitute these values in dy by dx. We get x is equal to 0 gives you dy by dx greater than 0, and 6 gives you dy by dx less than 0. So the first graphs gives you a minimum value, a minimum shape. Just see the shape. And second graphs give you the maximum shape. You can use this method also. So here x is equal to 16 gives you the point minimum and x is equal to 4 maximum. Most correct expressions of dy by dx were successfully differentiated to obtain the second derivative correctly. And the third part, nearly all candidates who appeared this part used their results from part 2 to examine the sign of the second derivative for the values of x. From part 1, the use of the sign change in dy by dx around the turning points was rarely seen. That means most of the students have used d square y by dx square. Rarely students used dy by dx to find the nature. Next question is, the tangent to the curve y is equal to x cube minus 9x square plus 24x minus 12 at a point A is parallel to the line y is equal to 2 minus 3x. Find the equation of the tangent. At A, it's a 6-mark question. So understand, we have a tangent at a certain point of the curve, and this tangent is parallel to the given line. We have to find the equation of the tangent. So here, consider the equation of the curve. and there is a line which is parallel to the tangent, and the equation of the line is y is equal to 2 minus 3x. Let's consider its diagram. So there is a curve which is having a tangent at point A. Okay, and there is a line which is parallel to the tangent. Here the line is that orange line. Okay, this line and the tangents are parallel as per the question. Okay, and now we have to remember about parallel lines. Okay, so here as the tangent is parallel to the given line, they both have the same gradient. Remember the concepts of gradients. For parallel lines, gradients are equal, and for the perpendicular lines, product of the gradients is minus 1. Remember that concept. Okay, and to find the equation of tangent, to find the equation of tangent is a straight line. We have to use the formula from coordinate geometry. Remember what's the formula, which is y minus y1 is equal to m of x minus x1, isn't it? Okay, so here what is m is the gradient, that is gradient of the line. As the gradient of the line is same as gradient of tangent, we can use m as the gradient of the line, and x1 y1 gives you the point of intersection of tangent and the curve. Okay, so our first task is to find the gradient of the tangent, which is same as the gradient of the line. And as we know, gradient is same as the derivative of curve at a certain point. What we do, so let's use our plan 1. Let's make it as different plans. Okay, always we require plans for doing a problem. So our first plan is derivative of the curve is equal to gradient of the tangent, which is same as gradient of the given line, as the line and the tangent are parallel. Using this, we can find the value of x, which is the x coordinate of the point of intersection of the curve and the tangent. Okay, so we are going to find the x coordinate of the point of intersection with the help of gradient of the line and the derivative of the curve. So let's find the gradient of the line. Our line is y is equal to 2 minus 3x. It is in the form of y is equal to mx plus c. So we can find the coefficient of x is minus 3, which is the gradient. Now our next step is to find the derivative of the equation of the curve. So when you derive it, we get dy by dx equal to 3x square minus 9 into 2x plus 24, which is equal to 3x square minus 18x plus 24. Okay, as dy by dx is same as gradient of the tangent, we can understand dy by dx is equal to minus 3, because gradient of the tangent is minus 3. Now when we replace dy by dx, we get 3x square minus 18x plus 24 equal to minus 3. When you consider minus 3 to left side, we get 3x square minus 18x plus 24 plus 3 equal to 0, which is 3x square minus 18x plus 27 equal to 0. Now solve this quadratic equation. We get the value of x. Here we get both the values of x are equal because roots are real and equal. Okay, so x is equal to 3. Now substitute this value of x in the equation of the curve, don't substitute in y is equal to 2 minus 3x because that is another line. There is no connection with the line and curve. So substitute this value of x in the curve, we get the y coordinate of the point of intersection. So when we substitute y is equal to 3 in the equation of the curve, we get y equals 3 cube minus 9 into 3 square plus 24 into 3 minus 12, that we get as y equals how much? 6. So what is the point of intersection? 3, 6. Okay, that is the intersection of the point of curve and the tangent is 3, 6, coordinate 3, 6. Okay, that means that point of intersection is 3, 6, and we already got the gradient of the tangent as minus 3. So our plan 3 is to find the equation of the tangent. So equation of the tangent is y minus y1 is equal to m of x minus x1. Replace the values correctly, as x1 y1 is 3, 6 and m is equal to minus 3. We get y minus 6 is equal to minus 3 of x minus 3. Okay, now you can simplify this answer as y minus 6 is equal to, expand the bracket in the right side, we get minus 3x plus 9. Now arrange all the terms in one side except y as the subject. Y must be the subject. We get y is equal to minus 3x plus 9 plus 6. That is y is equal to minus 3x plus 15 as a result. Question: the function f is defined by f of x is equal to x cube minus 9x square plus 24x minus 12 for x greater than k, where k is a constant. Find the smallest value of k for f of x to be an increasing function. So recall the concept of increasing function where the derivative is greater than 0. So as per this question, derivative is f dash x, that must be greater than 0. So here when we find f dash x, we already found f dash x in the previous part of this question. We get it as f dash x is equal to, the derivative of x cube is 3x square minus 9x square is 18x plus 24x is 24 minus 12 is 0, and that is greater than 0 as it is an increasing function. 3 is common in every term, so if you take it outside, we get 3 of x square minus 6x plus 8 greater than 0. That implies 3 of x minus 2 into x minus 4 greater than 0 after factorization. So the critical values are x is equal to 2 and x is equal to 4. Okay, so with the help of critical values, so critical value stands for nothing but stationary points. The x coordinates of the stationary points are x is 2 and x is 4. Okay, so what is the next step? Remember the concept of quadratic inequalities. Ax square plus bx plus c greater than 0 gives two solutions. One is x less than r1 and the other is x greater than r2, where r1 is the smaller root than r2. Here the smaller root is 2 and the bigger root is 4. So we get x less than 2 and x greater than 4. We learned this concept in chapter 1, quadratics. So when you mark these stationary points in a curve, let's consider that point as 2. That stationary point is 2 and the next stationary point is 4. So let's mark that one as 2 and the second stationary point is 4. And when we consider our range of solutions, Remember this range of solutions we got now? It's nothing but x smaller than 2 and x greater than 4. So if we find this part in the graph, we'll get x smaller than 2. Where is x smaller than 2? Can you say where is x smaller than 2? Yes, the left side of 2, that is x smaller than 2 and x greater than 4 is the right side of 4. That gives the increasing part. You see the graph, it is the increasing part, and that part gives the decreasing part, x smaller than 2. And remember, our question is the increasing function, that is greater than 0 and this is less than 0. Okay, so our function is an increasing function. So x smaller than 2 makes the function decreasing because that value makes f dash x negative, and x greater than 4 makes the derivative positive. So x greater than 4 and x greater than k, if we compare, we get k is equal to 4. Examiner report. In part 1, almost all candidates were able to differentiate correctly and a high proportion went on to equate to -3 and proceed to a correct answer. That was the thing we have done here. Some candidates, however, equated the derivative to 0 while others equate to 2 minus 3x or to 1 by 3. So remember, when we equate to 3, 0 and 1 by 3. In part 2, most candidates either set their derivative equal to 0 or to greater than 0 and either factorized obtaining the values of 2 and 4 or less frequently applied a completing the square approach, obtaining x minus 3 the whole square minus 1 greater than 0. The first approach required candidates to choose one or the other of the critical values and a significant number incorrectly choose 2. In the second approach, several candidates concluded that x and therefore k should be 3. Despite these errors, this question proved to be a very good source of marks for many candidates. So read this examiner report very well and identify the common errors made by the candidates and what's the correct method chosen. Okay, thank you very much.